The remotely operated vehicle spotlight sweeps across the seafloor, and there it is, a seam running ruler straight through black basalt for 7.6 meters. Joint tolerance averages under 2 millimeters along the entire length, confirmed by photogrammetry. The block it divides weighs between 80 and 120 tons, heavier than a fully loaded freight rail car. The stone surface is matte black, biofilm settled in the recesses, and laser measurement dots slide cleanly across faces that remain impossibly flat. The official view calls this natural fracturing combined with erosion patterns, but fractures do not run straight for meters at a constant depth and angle. This seam is straighter than most modern underwater concrete joints. If this is not natural, then our assumptions about human access collapse. Depth limits, timeline constraints, and available tools all start to wobble. Here's the uncomfortable part. This is the least precise surface down here. The structure sits between 32 and 38 meters below the surface, revealed when the remotely operated vehicle cameras first mapped it in detail. What immediately catches your eye is not the size, though that is overwhelming, but the geometry. Steps: a platform face rising 1.8 meters, then a tread extending 3.2 meters, then another riser of 1.8 meters. Right angle corners, repeating step geometry that continues across the visible formation. The official record calls it a terraced seabed rock formation. Natural terracing exists. Wave action, differential erosion, and layered sedimentary deposits can create step-like features, but they do not repeat uniform riser heights. Natural processes do not remember the last step's measurements when carving the next one. Modern ROV grid mapping reveals something unsettling. The pattern consistency holds across mapped sections. The steps do not drift in height. They do not wobble in depth. They maintain proportions like someone was checking their work. Planning is implied. Repetition suggests intention. Uniformity is never accidental. Move closer to where two blocks meet at a corner junction. The remotely operated vehicle's arm extends a laser measuring tool. The corner angle reads 89.9 degrees, not 85, not 93. Within 1/10 of a degree of a right angle. The edge itself remains crisp, despite erosion visible elsewhere on the formation. You can see the sharp shadow it casts under raking light from the vehicle's floodlights. The standard explanation points to erosion-resistant basalt properties. Basalt is hard, dense, slow to weather, but erosion doesn't preserve edges. It rounds them first. Corners and edges present maximum surface area to abrasive forces. Waterborne sediment attacks exposed angles relentlessly. Yet here, where edges should be the first casualties of time, they remain knife-sharp. Under carefully angled light, the edge shadow stays crisp for its entire length. No rounding, no degradation to a softer profile. The implication creeps in quietly. This precision existed before submersion, protected from the forces that should have destroyed it. So when did the water arrive? The mainstream dating places this site's exposure well after the last glacial maximum. Sea levels have risen approximately 120 meters since 20,000 years ago. The sediment layering visible atop some blocks suggests the structure was inundated by gradually rising seas, not formed underwater. Yet the official position maintains that it formed underwater. Look at the sediment itself. Stratified layers of silt sit atop the blocks, the kind of gradual accumulation you would expect from thousands of years of marine deposition. But beneath those layers, at the stone surfaces themselves, there is evidence of weathering patterns inconsistent with constant submersion. Some surfaces show wear patterns matching subaerial exposure, the kind you get from rain, wind, and temperature cycling, not from gentle underwater currents. The water came second, the structure came first, which means someone built this when the seafloor was dry land, when the coast was 120 meters lower, when the human timeline supposedly lacked the organization and tools for projects like this. And that is where the official story starts creaking. Switch your attention to a vertical face in the lower platform section. Under magnification, linear grooves run parallel across a span of 60 centimeters. Each groove measures 3 to 5 millimeters wide. The profiles are V-shaped when viewed in cross-section, narrow at the bottom and wider at the surface. This is the signature of deliberate tooling, not natural jointing. Natural jointing in basalt creates fracture patterns, but it does not repeat spacing with this regularity. cooling cracks, tectonic stress fractures, and erosion channels do not maintain consistent width and depth across multiple parallel lines. Digital edge profiling confirms what your eye suspects. These grooves share dimensional characteristics. They were QT, not formed. The record says natural jointing, but jointing does not care about spacing intervals. Jointing does not create V-shaped profiles. Jointing does not run in parallel sets, like someone dragged a tool repeatedly, deliberately, with consistent pressure across a vertical face. And the grooves show directionality. They show intent. They pose an uncomfortable question. If these are tool marks, who was standing here when this surface was dry, working stone at a location that would not be dry again for 20,000 years? Now examine an anomaly in the debris field. One block sits isolated roughly 14 meters uphill from the main cluster. It is not where gravity would put it. The displacement required moving this mass upslope on terrain with an incline of less than 4 degrees. There are no downslope tumble scars, no trail of impact marks, or disturbed sediment suggesting it rolled into position during some catastrophic event. The official explanation invokes tectonic activity. Japan sits on active fault lines, and periodic earthquakes reshape the landscape. Surely some ancient seismic event shifted this block from the main formation, but tectonic forces do not move single blocks cleanly uphill while leaving surrounding material undisturbed. They crack foundations, topple structures, and create chaos. They do not relocate 180-ton block 14 meters upslope while neighboring blocks remain in neat geometric arrangements. The block did not roll. It did not tumble. Something placed it there, or it was placed there before whatever event scattered the surrounding debris. Either scenario contradicts the natural formation theory. Either scenario requires agency. Consider the material itself. Basalt. Density approximately 3,000 kilograms per cubic meter. Compressive strength exceeding limestone by a factor of 2. This is not soft sedimentary rock that yields to copper chisels and patient grinding. Basalt resists fracture. It demands harder tooling to shape with precision. Experimental archaeology has tested ancient tool replicas against basalt. Stone-on-stone percussion, the technique attributed to builders working with primitive tools, produces crude fractures, not clean faces. You can break basalt with stone hammers. You can rough shape it. But creating flat surfaces with 2 millimeter tolerances requires something harder, something that can abrade and smooth without shattering the working edge every few strikes. The claim that these surfaces resulted from stone beating stone fails here. The mathematics of material hardness are unforgiving. To shape basalt precisely, you need tools harder than basalt. Bronze Age tools, copper and bronze implements are softer on the Mohs scale than basalt. They deform before the basalt does. That raises the question, what exactly were they using? Step back and look at the blocks in aggregate. When you measure the proportions, length to height ratios across different sections of the site, a pattern emerges. The ratio averages around 1.7 to 1. Not every block, but enough of them that it stops looking random. Length to height ratios consistently hover near 1.7 to 1. The official record dismisses this as coincidence. Natural fracturing does not respect human aesthetic preferences, so any apparent ratio must be selective observation, cherry-picking measurements that fit a pattern while ignoring blocks that do not. Except algorithmic clustering analysis, which treats all measured blocks equally without human bias, confirms the ratio concentration. There are more blocks clustered around 1.7 to 1 than a random distribution would predict. Random fracture lacks ratio memory. When basalt cracks under stress, it does not remember the last crack's proportions. It follows internal stress patterns, flaws in the crystal structure, and thermal expansion differentials. These forces are chaotic at the scale of individual blocks. They do not produce dimensional consistency across a formation. Yet here it is, proportional design consistency, repeating like someone was following a template. Design fingerprints emerge from the measurements whether we want to see them or not. Examine the construction in layers. The lower platform, the foundation level, uses blocks in the range of 80 tons or more. Massive, fitted with minimal gaps. The surfaces meet cleanly, joint lines barely visible in places. This is large block masonry, the kind where precision in placement matters, because you cannot adjust a misaligned 100-ton stone after you have set it down. Now look at the upper sections, what remains of structures built atop the platform. The stones here are smaller, under 2 tons typically. The masonry style changes entirely. Gaps appear between stones and are filled with smaller fragments. The fitting is rougher, less exacting. This is gap-filled masonry, a different construction language. The official narrative presents single-phase construction, one culture, one time period, one building event. But the methods are incompatible. Large block precision fitting requires different logistics, different organizational capacity, and different expertise than rough gap-filled masonry. You see this pattern repeated at sites worldwide. Massive, precise foundations supporting later cruder additions. 2 builders, 1 site. The foundation speaks one language. The ruins above speak another, and no one can quite explain why the earlier layer, supposedly built by less advanced cultures, shows superior technique. Weathering tells its own story, and the story has chapters. Examine the edge recession on the foundation blocks versus the upper structures. The massive base platform shows edge recession under 1 millimeter, corners still sharp, faces still relatively crisp. The upper masonry shows edge recession exceeding 10 millimeters in places, rounded corners, softened profiles, surfaces degraded by exposure. Weathering operates at known rates, influenced by material hardness, environmental exposure, and the chemical composition of rain and atmosphere. Basalt weathers slowly, but it weathers consistently when exposed to the same conditions. If these structures were built simultaneously and weathered under identical conditions, they should show similar degradation profiles. They do not. The shadow retention under raking light reveals the difference starkly. Foundation blocks cast sharp shadows. The edge geometry remains defined. Upper blocks cast softer shadows. The edges have been rounded by thousands of additional years of exposure. The official narrative claims uniform aging, one construction event, one weathering timeline. But micro-erosion modeling contradicts this. The base platform has been exposed to weathering forces for significantly less time than the structures above it, or it was protected by something that the upper sections were not. Time did not pass evenly across this site. The stones remember different histories. Search the archaeological record for coastal settlements that could have supported a construction project at this location during the time when it was above sea level. The nearest known habitation from the relevant time period sits more than 40 kilometers away. No settlements, no permanent structures, no evidence of the population density required to organize labor, transport materials, and execute construction on this scale. Logistics requires people. You cannot move blocks weighing 100 tons with a dozen workers. You need hundreds for transport, for positioning, for the support infrastructure that keeps a labor force fed and housed. You need specialists who understand stone, engineers who can plan the work, administrators who coordinate the effort. You need a society dense enough and organized enough to mobilize these resources, and there is no trace of it. Local oral histories, when they mention the site at all, offer no construction narratives, no legends of great building projects, no stories of ancestral architects. The cultural memory is blank where it should be richest. If a local population built something this significant, they would remember. They would pass the story down. The absence is suspicious. Who built without witnesses? Who built without leaving themselves in the cultural record? Or perhaps more unsettling, who was here building at sea level before the cultures we can trace even existed in this region? The uncomfortable part is not that this structure exists. It is that it exists alongside others, eerily similar. Submerged step formations with comparable geometry have been documented elsewhere. The riser heights cluster around 1.7 to 1.9 meters across different sites. The construction signatures include large block foundations, precision fitting, and geometric repetition, and they appear in locations separated by thousands of kilometers. The official record treats these as independent coincidences. Different cultures, different times, different regions, all supposedly arriving at similar solutions to similar challenges, but they did not all face similar challenges. These sites represent different environmental contexts, different available materials, different coastal configurations, and yet the errors, if we accept the natural formation theory, repeat. The same improbable geometry, the same suspicious precision, the same construction languages appearing in foundations separated by oceans. Cross-site photogrammetry reveals shared mathematical relationships in the proportions, the angles, and the dimensional ratios, not identical, but related like dialects of a common language. Either natural processes somehow converge on similar outcomes across vast distances, or something else is operating. Patterns do not respect borders. Geometry does not care about cultural isolation. The stones are speaking a language that predates the cultures we credit with their construction, and nobody wants to acknowledge what that implies. Flood myths appear across cultures. Stories of rising waters, sunken lands, stone places claimed by the sea. The timelines these myths reference, when you strip away metaphor and symbolic language, loosely align with the periods of rapid sea level rise at the end of the last glacial period. The stories speak of cities beneath waves, of architectural achievements lost to water, of civilizations that existed before the flood. Mainstream scholarship dismisses these as legend, cultural memory distorted beyond historical usefulness, symbolic narratives not meant to be read as literal history, and there is truth to that caution. Myths do not move stone. Stories do not explain how 100-ton blocks were positioned with millimeter precision. But myths do something else. They remember. They preserve fragments of knowledge across generations, even when the context is lost. The overlap between mythological geography and submerged structural evidence is harder to ignore than it used to be. Multiple cultures, separated by oceans and millennia, reference sunken stone architecture in their flood narratives. We have now found submerged stone architecture in regions where these myths persist. The myths do not prove the structures are artificial, but they do suggest that someone, at some point, remembered them differently than we do now. Stories persist longer than walls. Memory outlasts stone. And sometimes, when you stand at sites like this, the myths suddenly sound less like fantasy and more like corrupted history. They are fragments of witness testimony passed down until the context dissolved, but the core, stone underwater, built before the flood, remained. The evidence stacks, but it does not conclude. We have depth, 32 to 38 meters below current sea level. We have mass, individual blocks weighing 80 to 120 tons. We have precision, joint tolerances under 2 millimeters and corner angles within tenths of a degree. We have length to height proportions clustering around 1.7 to 1 across the formation. We have tool marks, linear grooves with V-shaped profiles suggesting directional working. We have weathering differentials, foundation blocks showing significantly less erosion than superstructures. We have construction signature mismatches, massive precision fitting at the base, and crude gap-filled masonry above. We have logistics gaps, no contemporary settlements within viable transport distance. We have global parallels, similar geometry and construction techniques in submerged sites across different continents. The site remains intact, unexplained. The official record holds that it is a natural formation, but that explanation addresses features individually, never confronting them together. Natural terracing might explain the steps, erosion might explain some surfaces, tectonic activity might explain some displacement, but could all of these processes, operating simultaneously, produce this specific combination of geometry, precision, and proportionality? The mathematics become uncomfortable. The final question is not whether ancient humans had the capacity. Clearly, someone did. The question is this: if humans could not access this depth during the accepted timeline of technological development, why does every measurement, every angle, every proportion, every construction signature look exactly like intentional human architecture? Why does the impossible object sit there, defying our comfortable timelines, refusing to dissolve under scrutiny? The ROV laser grid fades across a perfect seam, 7.6 meters of precision cutting through black basalt underwater, and the seam does not answer. It just measures, unchanging, impossibly straight.